Dark matter is everywhere. Dark matter is simply matter with no apparent electrical charge. It is present wherever there is visible matter. Here is why. Visible materials. The analysis of visible materials shows a common point. They all have a non-zero electrical aspect. Either their electric charge is non-zero, for example, electron. Either their electric moment is non-zero, when their electric charge is zero. For example, the neutron. The existence of the electric moment induces a magnetic moment. Visible matter always breaks down into smaller electrically charged elements, or this matter is itself electrically charged. We deduce that dark matter has a zero apparent electric charge and a zero apparent electric moment. For example, the neutrino, nu, and their apparent magnetic moment is zero. Dark matter quantitate. The only possible quantitate in the Standard Model is the neutrino nu. The new neutrino was detected during beta decay. During this event, a collision between a proton and a neutrino took place. This collision gives rise to a mu meson and a pi meson. Here is the equation. P plus the proton add nu the neutrino equal gives mu minus, it's the mu meson, it's just a mu plus a pi meson, double charged, positively charged. Here is a photo of a proton and neutrino collision from Argonne National Laboratory. We can see a thick line, the proton path on the top right. At the point of collision, an invisible neutrino collides with the proton, give a neutrino transformed into mu meson and a pi meson. Annihilation according to SM. According to the Standard Model, the annihilation of an electron and a positron gives two photons. Electron minus plus E plus gives gamma minus plus gamma plus. gamma is a photon, E is a electron or positron. But this equation flagrantly violates the law of conservation of matter, because the electrical charge disappeared. We know the electron contains photon by Compton effect. When the electron in movement is slowed, the electron will liberate the photon. So we can consider the electron contain photon. When photon is liberated, the charge disappears. To remedy this, we must add an invisible particle, but the only one possible in the standard model is the neutrino nu. So we have the equation here: E minus plus E plus equal to gamma minus plus gamma plus nu. Neutrino modeling. We deduce from this nu equal to parenthesis E plus minus gamma E minus subtract gamma minus plus parenthesis E plus subtract gamma plus. So the neutrino nu is composed of an electron having lost its main photon and a positron having lost its main photon. It's a couple of charge. We know that the neutrino has a very low mass. This allows us to assume that the electron and the positron each have a residual photon. Question: how does the new couple behave? Static or dynamic? This question will give rise to a new model of fundamental particles. Dynamic modeling of the neutrino. We can model the new neutrino as a couple of electrical charge, a electron and a positron. When the electron orbits the positron and vice versa, their trajectories form a circle of radius r. V is the tangential rotational velocity. The electric force that attracts the electron and the positron is balanced by centrifugal force. There could be different energy level for the neutrino depending on the orbital velocity v. Orbital rotation cancels out the apparent electric field and electric moment. Another non-standard model. Another model named Xizhidong abbreviated as XM. XM will describe the details of the following: elementary particles, the neutrino and its family, the chrominates compounds, the nucleonates compounds. This will make it possible to predict the composition of the dark matter. XM elementary particles. There are only two following elementary particles: the photon and pure electric charge. Photon has two polarity, plus and minus. Plus when the photon has its rotation around its direction of travel, following the right-hand direction, and in the otherwise it is minus. The electric charge we have plus and minus. XM structure of an electron. Electron is modeled as a pure electric charge containing a photon. Structure of a positron. The position is the same. It's just a plus electric charge and a plus photon. Structure of a neutrino and its family. We have seen the neutrino model, and the neutrino is a name given by Standard Model. But in XM, we have a different definition. In Standard Model, neutrino is a fundamental, elementary particle. But in XM, neutrino is a composite. It's a composed particle. Is not an elementary particle. And the neutrino is composed of an electron and a positron. In XM, this structure is called a charginate. Indeed, there are different energy levels for the charginate depending on V. The rotation of the charginate cancels out the electric field and the apparent electric moment. This rotation also gives its properties a disk-like appearance. A neutrino is a dynamic composed particle. It is not an elementary particle in XM model. XM structure of a chrominate up. In XM, three charginates form a stable triangular chain. This stability is ensured by the electric force at these three contact points, which are the three vertices of the triangle. The green charginate has a nominal speed of 3v. In XM, this structure is called chrominate up. This compound particle is electrically neutral. Structure of a chrominate down. Similarly, we can construct a chrominate down with another combination of charginates with different level of energy. The blue-orange charginate has an orbital speed v. In XM, this structure is called chrominate down. This combined particle is electrically neutral. XM composed of chrominates, twin chrominate up. We take a chrominate up and two charginates with low level energy and construct with the high level energy charginate. We obtain a twin chrominate which share a common charginate. Composed of chrominates, twin chrominate down. We can do the same with different level energy. We obtain twin chrominate down. If we put an electron into one of the chrominate, we obtain a mu meson. Double chrominate down. If we construct a chrominate from a chrominate up, we construct with the one of the three side, we obtain a double chrominate down, because there is three charginates with high level energy and two charginates with lower energy, so it is down. Double chrominate up. With the same configuration, we have only two charginates with high level energy and three charginates with lower level energy. So it is a chrominate, the double chrominate up, because we have two chrominates that share a common charginate. We continue our construction. We can obtain triple chrominate. Here is a triple chrominate down 3, 4. 3 means we have 3 charginates with lower energy and 4 charginates with higher energy. Triple chrominate up 4, 3. 4 charginates with lower energy and 3 charginates with higher energy. Triple chrominate down 2, 5. This is the same principle. We have 2 charginates with lower energy and 5 charginates with higher energy. Analog. Triple chrominate up 5, 2. Structure of a nucleonate down. Starting with the up chrominate called a hurt, which has 3 sides. The construction continues with the same principle as a chrominate on its three sides. We obtain a down nucleonate. This structure is electrically neutral. It is called nucleonate because if we put electron and positron in chrominate, we will obtain a nucleon. A nucleonate is a nucleon which lost their electron or positron. Representation of a down nucleonate. The down nucleonate has an axis of symmetry that passes through the center of the core and parallel to the three charge-nates of the core. The view along this axis can be represented by the diagram opposite. We have a triangle in the center and three ellipses in the periphery. The structure of a nucleonate up, starting with a down chrominate called a hut, which has three sides. The construction continues with the same principle as a chrominate on its three sides. We obtain an up nucleonate. This structure is electrically neutral. Representation of a nucleonate up. The up nucleonate has an axis of symmetry that passes through the center of the core and parallel to the three charge-nates of the core. The view along this axis can be represented by the diagram opposite. XM proton-neutrino collision result. In this figure, we can see a proton P+. It is just a nucleonate. It is an up nucleonate with two positrons and one electron in three chrominate with a neutrino. It is a charge-net, a green, with a higher energy. And the collision will give a pi meson and a mu meson. The mu meson has an electron inside, and the pi meson has two positrons inside. XM proton-neutrino collision process 1. At the first time, the collision will give a mu meson and a pi fragment, because the proton contains a mu meson and two fragments. XM proton-neutrino collision process 2. Pi fragments adds neutron to give pi meson. the neutrino is in the shared charge net. This combination is possible because they come from the same atomic nucleus during beta decay. XM, bond between nucleonates, dynamic link between nucleonates. It is established between two parallel nucleonates because each nucleonate has an axis of symmetry. We can put the two nucleonates in parallel situation by their axes. A dynamic bond is of positive energy. Such a bond consists of 8 pairs of electric charge of opposite signs. These charges are in charge net orbital rotation. Each pair of charge meets at a point of contact once per period. All the charge nets are in synchronized rotation. XM composed of nucleonates. We can have 2 nucleonates or 3 nucleonates here. They are linked by the dynamic link. These figures are for 4 nucleonates. This figure is for 5 nucleonates and 6 nucleonates. Other composed of nucleonates are also possible. Based on the particle described, it is also possible to construct additional combinates by adding charge nets. But the stability of the particle thus obtained is uncertain. Balance of dark matter elements. There are a large number, more than 10, of neutral particles constituting dark matter. Neutral interactions. Considering the electrical neutrality of neutral particles, the interaction between neutral particles is gravitation. The interaction between a neutral particle and an electrically charged particle is also gravitation. In astronomy, observations show that there are more neutral particles than charged particles by mass, which allows us to deduce that we live in an ocean of neutral particles. Useful links for more details. https nostandardmodel.org, http jax.dong.free.fr.